there were two minima at negative root 2 over 2, negative 17/4, and positive root 2 over 2, negative 17/4.
I just didn't write down the negative one.
And there was a maximum at 0, negative 4. Okay. 5, there was a minimum at 0, negative 5.
That was the minimum or the maximum?
That was the minimum.
Oh.
And there are two maxima at negative root 2 minus 1 and positive root 2 minus 1.
I just keep forgetting the minus.
Number 7.
I'm not stupid anymore.
It's my turn today.
Concave up from negative infinity to 2, and concave down from 2 to infinity. Number 9 was concave up from negative infinity to 3 minus the square root of 105 over 12, and from 3 plus the square root of 105 over 12 to infinity. And it was concave down from 3 minus the square root of 105 over 12 to 3 plus the square root of 105 over 12. And number 11 was concave up from negative infinity to infinity.
How do you know if it's concave up or down when it's the derivative is just like a number? Like I got negative infinity to infinity, but how do you know if it's concave up?
Well, you have,
Because
what was
the
your second derivative? 4. And since 4 is positive, then it will always be concave up. If your second derivative is negative, then it would always be concave down.
Okay.
I got the front page wrong. But it is the back page, right?
Okay. Do you want to go over some?
I don't know what I did wrong.
3 and 5.
Mm-hmm.
Do you want to just bring me paper? You can't do 2x out here because there's not an x with that one. So, but you left that as 2x squared, so then it wouldn't be 2, it would be 6.
I don't know what I can't.
Right?
Yeah.
So I think that's your problem. I'm thinking you have to, no, let's see. You didn't find the second, oh, you found, okay. So, well, wait, maybe you were doing this for the first one. To find the, okay, no, that's okay. So you were doing this for the first derivative to find the c's first. So you have 2x times 2x squared minus 1. That would be right. So then you got 0 or, and this would be plus or minus, since you're c squared. Okay, so those are fine. If you put them into the second derivative, you get, if you put 0 in, question is why is 0, oh it is, 0, negative 4 is the max. So you just put it, I don't know where you got negative 2, maybe you put it in the wrong thing. Well, you put it in here to determine if it's a max or a min. Since it's negative, we know it's a max, because it's concave down, but you have to put it back in the original to find the coordinate. Okay.
So you
So it's not that big of a deal.
plug back into the original.
Yes, to find the y coordinate. You're just using the second derivative to see if it's going to be max or min.
Okay.
Okay. Today we're gonna put it all together and use all of this stuff to help us graph functions. So if you get up your notes.
The TV was on,
Hmm.
the screen went blank.
Again? Second time today. Both for your guys' classes.
It doesn't like us.
Like, there's sometimes where I'm just silly and I just forget to put it up there. But then there's other times when it's telling me that it is up there and it's just not. Is it up?
Yep.
Okay. Okay. So with all of this information, we can sketch graphs of functions. Okay? So first we're gonna find the critical points. The critical points will tell us where the maximum and the minimums are, which we can tell if they're maxima or minima if we use the first derivative test, or we could also actually use the second derivative test for that too. You can use, if you like the second derivative test better, you can use that. Find the intervals on which it's increasing and decreasing, which you do need the first derivative test for that. And the points of inflection, and where it's concave up or concave down. Then we can graph it. Okay, so, where's your assignment? There's only 5, I think.
Yep.
Yeah.
So, let's do one together. Number 1. I would probably write that as -1/2 x squared minus x. Okay, so first we're going to find the derivative. So that would be -x minus 1. Put it to 0. Okay, so that is going to be a critical point. Since we have to figure out where it's increasing or decreasing anyway, we might as well just use the first derivative test. You might want to label your paper so you don't get confused. But you don't have to. Okay, so using the first derivative, if I put -1 in, or a point less than -1, so like -2, 0. If I put -2 in here, I would get a positive. If I
Plug
put
it into the,
derivative, that's why I wrote first derivative. And if I put 0 in, I will get negative. So that means it's increasing from -infinity to -1, and it's decreasing from -1 to infinity. And I also need to find what this point is, and is it gonna be a max or a min then? It's increasing and then it's,
so it's max.
so it's a max, and it's gonna be at -1, comma, what?
Is that when you plug it into the original?
Yes, original. What? Are you
10 over 2?
What?
10 over 2?
I got 6 over 2, which is,
I was getting. 4, yeah.
yeah, 4?
Because if we do -1/2 times -1 squared, that would be +1, so that'd be -1/2, minus -1, so it'd be like +1 plus 7/2. So that would be like 1/2 plus 7/2, so that'd be 8/2. So that'd be 4. make me think I'm wrong. Everybody get a different answer.
Well,
Okay,
I just can't use
okay, we're not saying that.
it. It's true.
Okay, so now we need to find where it's concave up and concave down.
So then you have to find the second derivative,
Correct.
which is -1.
Second derivative is -1, right? So that tells us that
It's
Decreasing?
concave down.
it's concave down for the whole time. So that tells us that it's concave down from -infinity to infinity. Okay,
And graph it?
yeah. Your assignment does also say to find the x and the y intercepts.
Can you what?
I'm trying to think if we can make an accurate sketch. So we know, basically all we know is there's a max. I mean, that's not all we know, and we know it's concave down. But without the x and the y intercepts, we can't be very precise, I suppose.
That's a good enough sketch. It gives you the general idea.
We only have 5 problems. We need to find the x and y intercepts. Okay,
Does
so
the,
Well, what is the y? X and
because
y
it says from -infinity to -1 it's increasing, so does the line have to be like a smiley face there? Or no?
no, increasing means it's going up.
Okay.
Concave up is smiley face, but
Okay.
it's concave down for the whole time. Alright, so let's find, so y-intercept is where the function equals 0. Or no, that's the x-intercept. So the x-intercept, that's the harder of the two for this one. Because we're going to have to set that equal to 0 and use the quadratic formula.
Ew.
So x equals
Nice.
1 plus or minus the square root of 1 minus 4 times -1/2 times 7/2 divided by -1. Oh, that's not bad. What was it, negative? No. 28 over 4, so 7? Oh, that's not bad. So it's basically -1 plus or minus the square root of 8. Or -1 plus or minus 2 root 2.
Why is it only 1?
Hmm?
Never mind.
So you can get approximations for that on your calculator, so you can put them on your graph. So -1 plus the square root of 2 square root 2. Is about 1.8. And -1 minus 2 squared 2 is about -3.8. So you should have an x-intercept about 2 and about -4-ish. The y-intercept would be where x is 0, so the y-intercept would be what? That one's easy.
3.5?
Yep. 7/2.
Wait, what?
You just put 0 in for x to find the y-intercept.
And what's the 7 halves do for graph?
That's where the y-intercept is. Right here. Should be about 3.5. That's where the y-intercept is. My graph isn't right because we didn't find them yet.
I don't even know what
The y-intercept is where it crosses the y-axis.
Oh.
It looks like yours already does that. Okay, ready to go? I can tell you're excited about that.
When you have, like, when you get like a root, you have to do plus or minus the root, like for, cause I got one of the x's.
Mhm.
2 squared 6/2.
That's right.
Why?
What are you finding?
I found the first derivative and then I set to 0.
Oh, okay. Yeah, the critical points should be at negative square root 6/2 and positive square root 6/2.
Do we have to count 0? That's 1, 2.
6
Oh yeah, and 0. What did you get?
I got root 3.
Root 3?
Mm-hmm.
Plus. So, did you factor out 2x
Mm-hmm.
or negative 2x?
I just took 2x.
Okay. So then you have negative 2x squared plus 3. Right?
Mm-hmm.
So negative 2x squared equals negative 3. So x squared equals 3/2. Right?
X squared equals 3/2.
Mm-hmm.
Oh, I dropped it.
You see?
Okay. And you put this back into the derivative, right? To test them for increasing.
That's what it did.
Yes. To find where it's increasing and decreasing. Is that what you're talking about?
Mm-hmm. Boston Day or Boston.